Welcome. I'm Dr.N.Revathi, Assistant Professor, PG Department of Mathematics, Sita Lakshmi Ramaswamy College. In this video, we are going to discuss about game theory in operations research. Overview: what is game theory? History of game theory, applications of game theory, key elements of a game, types of games, few strategies and mixer strategies, two-player zero-sum games. What is game theory? In strategic games, agents choose strategies that will maximize their return. Given the strategies the other agent chooses, the mathematics of human interactions. History of game theory. Von Neumann wrote a key paper in 1928. In 1944, Theory of Games and Economics Behavior by von Neumann and Montesquieu. Game theory booms after this. In 1994, Harshani, Noss, and Shelton win Nobel Prize in Economics for game theory work. Applications of game theory. Applications of game theory in mathematics, computer science, biology, economics, sports, game playing, psychology, law, military strategy, management, philosophy, and political sciences. Next one is key elements of a game. Players. Players means who is interacting. Strategies means what are their options. Payoff means what are their incentives. Information means what do they know. Rationality means how do they think. Basic terms used in game theory. Player, that is a competitor, individual or group or organization. Strategy, alternative course of action or choices. Pure strategy means using the same strategy each time. Mixed strategy means using the course of action depending on some fixed probability. Optimum strategy means the choice that put the player in the most preferred position irrespective of his competitor strategy. Next one is two-person zero-sum game. First we see the definition of payoff matrix. The representation of gains and losses resulting from different actions of the competitors is represented in the form of a matrix. Value of a game is the expected payoff outcome of the player when all the players of the game follow their optimum strategy. Fair game means value of the game is 0. This is a formulation of two-person zero-sum game. Here A1, A2, etc. AM are the strategies for player A, B1, B2, etc. BN are the strategies for player B. And AIJ is the payoff to player A by B when the player A plays strategy AI and B plays strategy BJ. Example, consider the game of the odd and evens. This game consists of two players A, B, each player simultaneously showing either of one finger or two fingers. If the number of fingers matches so that the total number for both players is even, then the player taking evens, say A, wins ₹1 from B, the player taking odds. Else, if the number does not match, A pays ₹1 to B. Thus, the payoff matrix to player A is in the following table. Next one is the optimum solution. A game can be solved by using the following three methods based on the nature of the problem. First one is a saddle point concept, that is a max-min and minimax principle. Games without saddle point, dominance rule, and graphical method. Min-max and max-min principle. Max-min means a row player, that is, a winning player will select the maximum out of the minimum gain. Min-max, that is, a column player, losing player will always try to minimize his maximum losses. Next one is saddle point. If the max min and min max values are same, then the game has a saddle point and is the intersection point of both the values. We see one example. In this example, first row, that is A1 row, the minimum value is 2. So the row minimum value is 2. In second row, the minimum value is 4. So the corresponding row minima is 4. In third row, the minimum value is 3. So row minima is 3. Like that, in the first column, that is B1 column, the maximum value is 8. In B2, the maximum value is 9. B3, maximum value is 4. In B4, maximum value is 8. Next, the maximum of row minima. In row minima, the maximum value is 4. So we have to select a 4. In column maxima, we have to select a minimum value. So in column maxima, the minimum value is 4. So the corresponding value 4 is a saddle point of this game. That is, value of this game is 4 and this corresponds to A2 and B3. So player A's strategy is A2, player B's strategy is B3. Next one is dominance property. Definition. A strategy is dominated by a second strategy if the second strategy is always at least as good regardless of what the opponent does. Such a dominated strategy can be eliminated from further consideration. The following rules of dominance is used to reduce the size of the matrix. First one is row dominance, second one column dominance, third one modified row dominance, that is average of rows. The last one is modified column dominance, that is average of columns. We see one example for dominance property. So thus in our example below, for player A, strategy A3 is dominated by the strategy A2 and so can be eliminated. So in A3 is dominated by A3, so we eliminate A3. We get the following reduced payoff matrix. So in this payoff matrix, we have to eliminate A3. Now for player B, strategies B1, B2 and B4 are dominated by the strategy B3. So eliminating the strategies B1, B2 and B4, we get the following reduced payoff matrix. So this is our following reduced payoff matrix. So in this matrix, eliminating strategy A1. A1 is dominated by A2. So we see that A should always play A2 and player B plays always B3. And the value of the game is 4 as before. Next we see another example. Specify the range for the value of the game in the following case, assuming that the payoff is for player A is like that. So in this first row, the minimum value is 1. In second row, the minimum value is -5. In third row, the minimum value is 2. In first column, the maximum value is 5. Second column, maximum value is 6. Third column, maximum value is 3. So among the row minima, maximum value is 2. So we have to select 2. Among the column maxima, the minimum value is 3. So we have to select 3. So here, maximum of row minima is less than or equal to minimum of column maxima. So not equal. So the game has no saddle point. But the value of the game lies between 2 and 3. Conclusion. Why is game theory a successful model? A wide variety of applications, concentrate map of rules of the game, how the game is played, knowledge of players at any given moment, ability to analyze complex problems. Thank you.